up your hand. Who here would consider themselves a gamer? All right, cool. Good news. Because there's a little bit of like gaming flavor here. I gave this talk at the conference yesterday. So it's kind of AI plus gaming, which is a little bit of what Aether does and what makes us kind of unique. So hopefully that's interesting to you guys. I'll kick things off with a little bit of an introduction. My name's Mark. I'm one of the co-founders here at Aether. You've probably seen words out there in the press regarding compute scarcity, right? It seems to be increasingly difficult for small to medium-sized companies to get access to compute. That's something that Aether addresses, but it's not the original problem that we started to address. So my background's in infrastructure building. I started in kind of oil and gas before moving into my first kind of entrepreneurial endeavor, which was a biotech company. Moved to China, got closer to manufacturing, aiming to kind of reduce the iteration cycle on these sensors. Raised a bit of money and then ended up exiting the company and found my way kind of gravitating back into infrastructure. Right, China does some pretty incredible kind of infrastructure works at scales that you almost don't see anywhere else. And at the time, there was some really, really cool cloud infrastructure around the GPU cloud for cloud gaming. Who knows what kind of cloud gaming is? Okay, cool. For those of you that kind of don't know, cloud gaming is where you effectively install a game in the cloud and then you stream the game to the user so that they don't actually need to have any processing capability on their device. It can be the oldest, crappiest phone or computer, and it's able to play pretty much any game at fantastic resolution. It's effectively as simple as converting a game into a video feed. Just like YouTube can be played on any device, you don't need a specific type of hardware to access YouTube. Cloud gaming essentially converts a game into a dynamic video stream, and it's really cool, right? It unlocks really cool gaming content for users that don't necessarily have high-end devices. We started there. I said the word GPU, so I'm sure a lot of you are maybe making a little bit of a connection. This was kind of the GPU cloud before we realized we would need the GPU cloud as much for AI. It was very high-performant GPU cloud focused on kind of low latency. Long story short, we saw some kind of pretty significant performance and scalability challenges within the kind of centralized version of deployment for that type of cloud. So we started Aether. And here we are today. We took a little bit of an additional AI focus that's kind of put us really on the map within the AI space, but we do still have a very strong foundation in both the gaming and the AI side that is all effectively united by this kind of GPU cloud. So what do we focus primarily on today? This is the key issue, one of the biggest issues in AI, right? What does AI need to grow, to how do you make an AI model more intelligent? Well, you throw compute at it and you throw data at it, right? Compute is a critical piece of the puzzle. GPUs, I say compute, but GPUs are essentially the same thing. I'm sure you've seen in the media, people like Elon Musk coming out saying things like GPUs are harder to buy than drugs. People like Zuckerberg out here purchasing just under $11 billion worth of equipment in one single hit. It's becoming increasingly difficult for startups and small to medium-sized enterprises to access this critical GPU resource. And that's kind of making it really, really hard for builders that are not just these really, really big tech companies to actually compete and build cool products. So we looked pretty deeply at that problem, and we kind of found there were 4 key facets driving the issue, right? We're not able to address all of them at Aether, but we are definitely able to address the bottom one. The top is, of course, buy pressure, right? The biggest tech companies in the world effectively have this insatiable appetite for compute. They can't get enough, right? It's funny, you may hear people talking about scaling laws, right? Effectively, we know that AI gets smarter if you just add more data and add more compute, right? It's that simple. So for these big tech companies that are thinking, hey, I want to win the AI race, which could be considered maybe the most important race ever run, right? They know that they just need to get as much of this compute and data resources they can. So that's obviously putting a huge amount of pressure on the traditional compute acquisition avenues like hyperscalers. The flip side of the buy pressure is, of course, supply, right? NVIDIA can only produce so many chips per year. They're limited by raw materials and production capacity, and that's really not enough to meet the global compute demand. Kind of driving all of this is LLM complexity, right? LLM is the acronym for large language model, right? GPT-3, GPT-4, those are large language models. What we're seeing is that as later stage models are released, more sophisticated, more capable models, they're effectively exponentially more expensive to train than their predecessor, right? So we're seeing this kind of exponential rise in the requirement for data and for compute to the extent that we're already being told that we've fully used all of the publicly available data out there in the world, right? We're now kind of looking for new data sources. We're looking for synthetic data as a solution, right? So there's a huge challenge surrounding these resources, particularly compute. Long story short, exponential increase in compute requirements as models get more intelligent, but within the time frame that these models are improving, we're not seeing an exponential increase in the amount of GPUs that NVIDIA can supply. We're not seeing an exponential increase in the performance of these GPUs. So it feels like there's this widening gap, right, between what these later stage models need and the compute that the market's able to provide. Finally, you have really just a very inefficient market, and this is where Aether kind of steps in, right? We took a look and did quite a bit of research around the utilization rates of enterprise-grade GPUs that are sitting in data centers. In particular, those GPUs that are purchased and owned by companies that buy this equipment for their own internal use cases, right? It's very different. Like if AWS buys equipment, they have all of the infrastructure and BD teams and sales teams to make sure that they can fully optimize that equipment with, by outsourcing it effectively to the market, right? But if I'm just a regular tech company, if I'm Uber and I buy a whole bunch of H100 GPUs, right? If I miss forecast, right, or if I have a production delay for my model training run, right, all of a sudden I've got incredibly expensive equipment that's just sitting there. And this is the most expensive compute that's ever existed, right? One H100 system, 8 GPUs within one box is effectively $300,000, right? And the cost of power, the cost of bandwidth, for the cost of kind of rental space within a data center to just kind of sit there while it's not being used is a massive risk to enterprise balance sheets. And what we thought was that if we could create this really simple infrastructure layer that allowed companies to very, very quickly attach their compute to a network, and then expose that compute to this broader kind of global demand ecosystem, that would be a really meaningful way to redistribute supply back into the ecosystem. So that's pretty much what Aether built. We're a decentralized enterprise-grade GPU cloud for AI and gaming companies, right? We aggregate often underutilized compute from tech companies, from enterprises, from data centers, from crypto mining organizations that might have, large amount of latent compute. And we then surface it and make it accessible to the global demand ecosystem. This is kind of a little bit of a system diagram, what it looks like, compute just flowing up into the Aether cloud. If you go and visit Aether's product, this is what you'll see. For anyone that has purchased compute before, this will be a very familiar experience. For those of you that haven't, just think of it like visiting a restaurant, right? You get a menu, and that menu will have all the different types of GPUs you might want to purchase. It'll have the location for those GPUs, how many of them are available, and what the price is, right? Prices in some regions are more expensive than prices in others as a result of many different factors. But effectively, you just go in, you select which compute you want access to, and then you make that transaction. The transaction happens in ATH token. That's the only real difference between what happens within the Aether platform and what might happen in a centralized equivalent. If, for example, you're a GPU owner, equally simple, right? You connect to our API, you can have your compute active within the network in around 10, maybe 15 minutes. The only difference there is you need to take some ATH token and stake it to make your compute live within the ecosystem. So what makes Aether different? I think the big difference for us has always been the fact that we have this like true enterprise focus, right? DPINs, particularly in the compute space, have tended to gravitate towards an aggregation of consumer GPUs, right? It's a great way to bootstrap a network. It's a great way to build really powerful community, right? You can kind of take your token, go to 10,000 gamers and say, hey gamers, if you give me your computer while you're asleep, I'll give you some tokens, right? And not only do you get their GPU into your ecosystem really, really easily, but they have a huge incentive to kind of shill your token and be bullish on what you're doing, because the higher the valuation of the token, the more rewards they will get for contributing their computer or their GPU to your ecosystem. So the consumer model has been very, very popular, but it has a challenge, right? And that challenge is eventually, right, despite what it might appear in crypto, eventually we want to sell stuff, right? We want to be a real business. We want to generate revenue. We want to have customers that are outside of just Web3. And those customers have pretty strict SLAs, right? They have pretty strict performance and quality and uptime requirements. And it's really, really difficult to meet those on the back of consumer GPUs, right? You can't necessarily guarantee that the owner of this GPU won't just switch their GPU off at night because their RGB goes too hard, right? Or this GPU owner won't have their bandwidth throttled because they're watching Netflix of an evening, right? Limiting your ability as a network to kind of pull compute out of their system. So it's really hard to build a kind of an enterprise suitable product on the back of consumer GPUs. And at Aether, we chose to kind of avoid this challenge and focus on something that's probably a little bit more difficult in the beginning, right? Aggregating truly useful enterprise-grade GPU compute. And that's effectively what we've done. So we've now got 42,000 plus enterprise-grade GPUs all over the world, contributing to enterprise workloads on the gaming or the AI side. And effectively, we have a network that's 100% synergous with the compute demands of the kind of enterprise AI and enterprise gaming ecosystems. Cool, this is a quick look at the kind of products that we have at Aether. Top two there, if you can't read it. On the far side, you have AI training. This is the application, this is the work for making AI more intelligent, right? If you take ChatGPT 3 to ChatGPT 4, that process is called training, right? On the right-hand side, you have AI inferencing. Inferencing is the word that we give AI for doing its job, right? So if you ask ChatGPT a question, it'll query the model and it'll send you an answer. That task is called inferencing, right? So AI applications live on kind of the right-hand side, like ChatGPT, for example, would live on the right-hand side, but going to ChatGPT 5 from ChatGPT 4, that would be on kind of the left-hand side with the training. And on the bottom side, you've got a lot of gaming compute, right? On the gaming compute side, bottom left, that's all kind of the mobile cloud gaming, PC cloud gaming, cloud publishing, which is a really cool product we have, and then kind of a little bit more of a corporate kind of virtual machine solution that we have on the bottom right with our virtual compute. That seems to be really popular with telcos at the moment. So this is where it gets a bit gaming, right? So this was actually the very first problem that Aether chose to tackle, right? We took a look at the broader gaming ecosystem, 3.3 billion gamers out there, right? 2.8 billion of them are gaming on low-end devices. And that's kind of it's a bit of a sad state of affairs, right? Because all of the games that maybe those of us in this room would consider mainstream are pretty much inaccessible to that 2.8 billion gamers, right? They don't have the hardware necessary to experience that form of content, right? But what's interesting, or what's the flip side of that, is that the biggest gaming companies in the world also don't have access to those gamers, right? This hardware is kind of a two-way barrier that's really kind of limiting accessibility to the vast majority of gamers out there, and that's kind of a massive challenge. It's arguably the biggest untapped, I guess, slice of cake left within the broader gaming ecosystem. And at Aether, we thought pretty deeply about, okay, what needs to change? What kind of needs to shift from a status quo perspective to unlock these 2.8 billion gamers? And really, in my mind, there's only kind of three potential scenarios that can result in these gamers being unlocked, right? First of all, make them all more rich, right? Give them enough money that they can all buy their own fancy phone, their own gaming PC, their own console. I think we can all agree, probably very unlikely. Maybe on the back of kind of AGI and universal basic income, and maybe some techno-optimists kind of see that down the road, kind of 5 to 10 years from now. Maybe that's something that wasn't in my original calculations pre AI pump. But the second one is, of course, all right, maybe we can make really powerful chips super, super cheap, right? Maybe there's some quantum leap in chipset technology, and all of a sudden we can create super powerful microprocessors that are really, really easy and cheap to distribute, and all of a sudden even the crappiest device has access to like a really powerful CPU and GPU, and they can play any games. So also probably pretty unlikely, not just from like a technological perspective, but also just from a pure kind of capitalistic human nature perspective. We'd probably still price it in tiers and exclude people. But again, scenario 2, not very likely. The third option, which is really, in my opinion, the only viable solution, is we take a technology we already have that removes the requirement for a user to have hardware, and we just solve the scalability issue. Right? This is cloud gaming technology. It's been around for 7, 8 years now, and the only thing that's stopping every single gamer in the world having access to any type of content they might want is the ability for this technology to scale into the regions or the parts of the world where people have that issue. Right? Google Stadia, for example, was Google's version of this technology. It was great. It worked in the US. But the centralized version of that technology was just unable to scale into the parts of the world where that technology would actually make sense, would actually be useful. And on the back of a DPIN, on the back of a decentralized compute network, you can bring these unit economics down. You can bring the cost of compute down to a place where all of a sudden it makes sense, right? All of a sudden we can now scale this type of technology into the markets, into the regions where these 2.8 billion gamers live, where this technology would really have a huge impact on not just the kind of the enjoyment and the kind of the experience of gamers in that region, but it would also unlock those gamers for the biggest gaming companies in the world, and I think that would be very, very cool on kind of 2 fronts. And just to give you an idea of where Aether is along this journey, we have this infrastructure scaling across Southeast Asia at the moment. We have it live in Latin America. We're not yet in India or Africa, but those are definitely on the roadmap. Of course, the infrastructure is also live across Europe and the US, but it has the most value, as you can imagine, in developing markets. So some highlights, I'll skip through these because you probably already know. TGE was middle of last month, which is pretty cool. Just before that, we did one of the biggest node sales in history, if not the biggest, raised about 150 mil or 42,000 ETH, selling about 72,000 checker nodes within our ecosystem. Our network, or our community, is now well over 1 million strong, with some of the biggest AI and gaming companies in the world scaling their products in the back of our infrastructure. We have around 150 people in the team, heavily distributed, but a couple of kind of key locations, headquarters in Singapore, NVIDIA partnership, among other kind of really cool high-profile partnerships that help us build really cool kind of cutting-edge stuff. And like I mentioned earlier, around 43,000 fully enterprise-capable GPUs that power both our AI experiences, but also our gaming experiences as well. Outside, you'll probably be able to see, I usually bring it with me, but it's actually at the Aether desk, is the Aether Edge, right? So this is actually like a consumer-grade computing device that you can purchase that effectively you plug in to your power at home, you connect to your Wi-Fi, and it operates as like an enterprise-grade node, an enterprise-grade AI node within Aether's ecosystem. It's pretty cool. We partnered with Qualcomm. It's got their latest AI chip inside it. You don't need to know how to run it. You plug it in, you just forget about it, and it operates as this node where we can send, as Aether, these enterprise workloads to that node, and as the owner of that node, when that node does work, right, on behalf of a customer, right, you earn rewards. So it's super cool. I think this is a massive, massive development. Think like a helium device from last cycle, but instead of it doing decentralized wireless, it's doing decentralized compute. And there's a lot of advantages that you may have heard about on other panels for compute, and compute that comes with kind of a low latency, right? So latency is effectively how quickly something can communicate with something else. And the closer you can put the hardware, the closer you can put where the compute happens to the user, generally the faster the hardware can communicate with the user. And if you think about when you're communicating with AI, right? It's kind of okay if you're just typing to AI to kind of sit and wait like a couple of seconds for AI to give you an answer. But if you kind of imagine looking at an AI avatar with like a face, right? And the face is just paused like a weird robot while it's like waiting for you to get your response. Like these are the challenges that we're gonna face as we start to progress outside of just a text-to-text interaction with AI. And devices like the Aether Edge are gonna be really cool for solving some of these critical latency-sensitive kind of edge-native problems that are out there in the world. Also, I will say that this chip, it doesn't provide GPU compute capable of, say, PC cloud gaming, right? There's not like a 4090 in there. It can't give you a Counter-Strike 2 experience, for example. But it can power mobile cloud gaming solutions. So actually, again, we talked about that 2.8 billion gamers that are on low-end devices. The vast majority of those are gaming on mobile, right? Low-end mobile devices. So this is actually empowering cloud gaming, mobile cloud gaming in developing regions as well. It's a pretty cool product for a number of reasons. It unlocks that capability within those regions. Also, it's a little bit of a financial independence solution for people that want a piece of the AI infrastructure pie in those regions as well. So it's really cool. That's something that we just launched recently. There's about 8,000 that have been sold to date in 4 kind of private 2,000 unit sales, but you can expect production and supply for that to be ramping up extensively over the next kind of couple of months, with hundreds of thousands of these being online probably by the end of the year. Anyway, that's all from me. Thank you so much for your time.